So I'm Jelte, and I'm going to talk a bit about the Postgres protocol today. What's good about it, what's bad about it, and what hopefully is the future of the Postgres protocol, but who knows. I'm a principal software engineer at Microsoft, and I do lots of Postgres-related things. I mostly work on PG Bouncer and Citus, and some Postgres patches sometimes, and reviews. So yeah, that's about me. So let's first start a bit simple. What is actually the Postgres protocol? What do we consider the Postgres protocol? And basically, it's how your query gets to the server, or how the results get from Postgres to your client. So it's not your query. Your query is like the letter in the envelope. The envelope is the protocol. And well, it's called the Postgres protocol. So is this thing only used by Postgres? Well, no, very much. No, it's not. There's a lot of databases that use the Postgres protocol. There's these ones, and there's probably more that I didn't find a logo of. And apart from other databases that use the Postgres protocol, there's also many clients and many connection poolers that implement it. libpq is the main client library, sort of in part of Postgres. It's like the official one. But many programming languages implement the protocol themselves. Some use libpq, but some actually implement the wire protocol and follow the spec, or try to follow the spec as best as possible. And connection poolers, I don't think any of them use libpq, so they also implement the protocol themselves. So why do all these databases and all these clients use the Postgres protocol? It's probably because it's very good, right? Why would you otherwise? And it is quite good. The one reason is because it has many, many clients. Sort of vicious cycle. Many clients equals good protocol for other databases, because then you don't have to implement any more clients. And implementing clients is quite difficult. Even like the Postgres community, there's many people implementing different clients, so it's very much spread out and lots of work for lots of people. So it's nice if you don't have to redo that if you build your own new fancy, of course, better database than Postgres, because why else would you build another database? And another reason is that it's fairly well documented. Another reason is that it's fairly well documented. Documentation is always hard, so there's some gaps. But certain other databases like Oracle, they sort of keep their protocol a secret, and you actually have to reverse engineer the client or the network traffic to be able to re-implement it. Postgres at least tries to explain in the documentation what the protocol is and how you can use it to send queries and get results back. And there's some edge cases that are, if you read very carefully, you might understand that that's what the docs mean, but otherwise you probably fail to interpret it correctly. But in the end, sort of also the protocol is a bit, whatever Postgres accepts from the way you send messages is kind of what's the protocol. If the documentation is a bit unclear, it's whatever Postgres accepts. But the documentation is fairly clear in the most obvious cases, at least. So what does the protocol consist of? Well, we're talking about the 3.0 protocol, which is the protocol version that everyone uses these days. 2.0 is 20 years old, so all the clients, all the servers. I think libpq doesn't have any support for it. PG Bouncer doesn't have any support for it. I don't think any client nowadays supports the 2.0, and the 1.0 I don't even know what it was like, honestly. The TCP, it's a TCP-based protocol, so it's really like you get a stream of bytes from the client to the server with all the guarantees that TCP give you. So if the network drops some stuff, it's going to get there eventually with some retries. And on that stream of bytes, Postgres sort of splits this connection into multiple messages. So you have messages, and they contain first 1 byte for the type, and then 4 bytes for the length, and then there's a bunch of other bytes, And those bytes, they're specific to the message. Based on the type, you can then parse those other bytes. But inside the protocol, inside this sort of very vague description, oh, you have a stream of messages, there's all kinds of different sub-protocols that you should know about, at least. And sort of read up on the ones that you care about and maybe not read up on the ones that you don't. So there's the startup, there's query stuff, there's copy, there's replication-related things, and there's cancellations. And all of these things, they sort of use the same building blocks, but they all work fairly differently in the end, the way they communicate. And I won't talk much about the logical or physical replication. One, because I don't know so much about it, and two, because what I do know about it is that it's a bit similar to the, it's very specific to how this replication works. So it's really specific to Postgres, and most other databases that implement the Postgres protocol, they also don't implement the replication protocol, especially the physical replication, because that's even sort of closer to, this is how Postgres stores blocks almost in the end. And the logical replication they could maybe implement, but it's both are very specific to Postgres. So instead, let's talk about the other things. Let's first start a bit with the startup. The startup is really different from the other messages because it's one of the only 4 message types in Postgres that doesn't have this type byte at the start. And that's because I said there is no 2.0 protocol message anymore, but the startup message is kind of a 2.0 protocol message. Just it only has like 4 bytes at the start, and that's where the protocol version is stored. And there's 3.0, it's always there. So it's like 4 bytes with always the same exact value, but that's how you know that you're, talking the same thing. If we ever upgrade the protocol, maybe that would change. And after that version, there's key value pairs. And that's really the only thing that's, other than that, that's in the startup message. You have a version and some key value pairs. And the only key value pair that's required is the user one. If you only specify the user, it will connect to the database with that username. You can also specify the database if you want to connect to a different database. And you can specify replication, which can be true or one, or a database name, depending if you want to do the logical or physical replication. But generally, you just don't. If you don't want to do replication connections, you don't specify the replication part. And it will connect as a user in a database. And then any key value pairs that you specify other than that, they're GUCs. Or, that's sort of what Postgres calls parameters, settings. If you do set work mem, then that's a GUC. And you can specify those in the startup message. And then there's a second way of doing exactly that as well, which is using an options key. And then there's this sort of, the value is then all the GUCs that you want to specify. And why that's the case is for historical reasons, for one, and also it's really the only way in which you can send arbitrary GUCs in the startup message with libpq. Many other clients, they allow you to say like, I want to put work mem in there, and they will actually put it as a key value. But libpq, it doesn't allow you to actually enter arbitrary key value pairs there. And as you can see, it's kind of a weird syntax. You have this -c and then work mem and then only the thing. Why is that -c there? What's up with that? Well, it's because, again, for historical reasons, it's not actually meant as sort of a, it's reusing the parser that Postgres uses to parse command line flags when it starts up, which is kind of, a weird choice, at the very least. And the documentation says you can do -c, but there's actually, you can specify other flags as well. You can do -e, which means date style is set to like a normal date instead of this weird American one with a month at the start. And there's like -d, and then you can specify a number, and And if you do 5, it sets all kinds of debug settings, and all your logs will be full of random things and plans. But no one really uses those, at least I hope, because I didn't implement any of the other flags in PG Bouncer, and I haven't had any complaints about it except for one format where you can actually, instead of using -c, you can do --, and then the actual name of the GUC. And some people were using that, but it was also not really documented very well. That's changed very recently, I think. So that one I've now implemented. It's not released yet, but -e and -d, I mean, unless someone really complains about it, I'm gonna say no, just don't use that. It doesn't make any sense. I'm not gonna do the exact same parsing as the Postgres startup thing. Postgres can reuse it easily. I don't want to rewrite it. So that's sort of how the startup message works. But that's only for unencrypted connections. And most people these days, because of the NSA and, I don't know, security, they kind of want to use encrypted traffic, especially to your database where all your important customer data is stored, and GDPR, and I don't know, all kinds of important things. So the way that works is that instead of sending a startup message, you send one of 2 other messages. You can do an SSL request or a GSS encryption request. GSS is LDAP or Kerberos. I never really use that, but other people do. So what happens is that you send that request, and Postgres just says yes or no back. That's what happens. And then based on that, you either start the encryption handshake, or you disconnect and reconnect, and continue without encryption if that's something you're okay with, if encryption is not supported by the server. But so you first ask if the server supports it, and only then you actually encrypt stuff. And these actually use also these version 2 message types where there's no type message. They instead use a magic version number for the protocol, which is 1, 2, 3, 4, 5, 6, 7, 9, and 1, 2, 3, 4, 5, 6, 7, 0. So if we ever get to protocol version 1, 2, 3, 4, we might have a problem, but I don't see that ever happening in, I don't know, not in my lifetime. And even if it did, I mean, we could just skip to 1, 2, 3, 5, and probably be fine. So yeah, that's sort of how the startup works. So let's continue to sort of what most people use Postgres for, running queries. So there's 2 ways of running queries, and the first one is the simple query protocol. And that's, I mean, as the name suggests, it's very simple. There's one message, query, and with a query type, and it contains a string, your query. And then the server sends back description of like what the columns are, and then a bunch of rows. And then at the end, it sends back ready for another query. So you can send another one, and you got all the data. And in that ready for query message, Postgres actually sends one little character that's very useful. And it can be one of three things. It can be I, which means idle, which means everything was good. You're back in sort of an idle state on this connection. You can send another query, everything is fine. It can be T, which is you're idle, but you're also in a transaction. So you have a transaction open, and the next query you're going to send is going to be part of that same transaction. Or something failed and you got an error, which means, I don't know, you have to do some cleanup, let the user know, something like that. And you might wonder, why is that T? Why is that useful? And it's actually super useful. For connection poolers, it's extremely useful because it means that the connection pooler doesn't need to parse, begin, or rollback, or commit. It can only, like a connection pooler, it's just for people that don't know, you have a transaction and you pipeline transactions from multiple clients over a single server connection. So you want that server connection to be handed off once the transaction finishes. So using this, you can see when a transaction is still in progress and make sure that it doesn't get handed off to a new client. Otherwise, you get two transactions mixing with each other, and everyone will be very, very sad. Because, I don't know, yeah, no one will know what happens. So yeah, that's the simple query protocol. And then there's the extended query protocol, which, as you can see, it's longer. So it's fairly much the same, but it's basically the query message is now split into 4 messages: parse, bind, describe, and execute. And as you can see, there's one, the bind is sort of, it takes a parameter list. And the query, it's not a complete query. There's like a placeholder, the $1. So that's kind of a big difference. Instead of having to make everything, instead of having to build a full query string, you can have parameters and the query template sort of separated. And another thing is that you can provide different column formats. You can say, I want the binary format or the text format for certain columns. So in this case, I said for the ID column, I wanted it in the binary format, and for the text column, for the name column, I wanted it in the text format. And that makes, for IDs, it might not matter a lot, but especially for instance, timestamps, they can be very CPU intensive to encode and decode to a string, because you need, for what is basically a number from like seconds from Unix epoch, you have to make this weird time string with time zones, and then that has to be done on the server, and on the client you have to parse that again and make it back into a number, which is just kind of a waste of both network traffic and CPU work. So it's kind of nice if you can specify that certain things are binary. With a simple query protocol, you cannot do that. Everything is always text. That's why it's so simple. But with this one, you have some more options. So that's one big benefit. And all the rest basically works the same. You have a row description, you have a data row, you again have ready for query. So apart from this binary part, why else would you use it? Because as it turns out, basically every client that implements the protocol uses only this one, or this one for the vast majority of the way it sends queries. It might have some option to send stuff with the simple query protocol, but the extended query protocol is the thing that basically everyone uses, except for psql, because psql is special. And the reason why they do that is because the splitting of parameters and the query string, it basically gives you free escaping of SQL stuff. So you don't have to worry about any SQL injection, because your parameters will be inserted correctly by Postgres into the query string, instead of you having to, before building the query string, have to escape all the semicolons and the quotes in whatever way Postgres likes that day. And yeah, so that's one big reason. Another is that you can actually use this in a bit more advanced way, where you actually specify a name for a statement, and that's called prepared statements. So you can have this query with many joins. We call it a hard to plan query, and then we can bind to it and execute it multiple times without having to send it multiple times to the server. So you can execute the same query with slightly different parameters over and over again. And that both reduces some network traffic, but especially it reduces some planning work on the server and some parsing work on the server, because it only has to do this planning and parsing once for the initial parse. And then that sort of combined work, it can be reused during the next executions. And there's another thing, which is query pipelining, which is also super, super useful. Because sometimes you want to send lots of queries, but you don't really care about the results, or you don't care about them right away. As long as they're all good at the end, you're happy. You want to send, let's say we want to insert 3 rows here. And yeah, so we insert 3 rows, and we can send all this stuff just in one go, and Postgres will then execute them and send back all the responses in one go as well. And we have this sync message at the end, which I didn't talk much about before. And that's because it's mostly important for query pipelining. Because here it doesn't even matter so much. But when it matters is when something in this pipeline fails. If like your this fourth statement, you insert Yoda a second time, you have a unique constraint on this name, and this one fails. So if you have all these queries in flight, what do you expect then to happen? Do you want the rest to fail? Do you want the rest to not fail? That's what the sync message is for. The sync message is sort of a marker telling Postgres, until the sync message, I want everything to be ignored, if anything, before it fails. So if you want everything to actually happen, you have to put sync in between all of them. You have to put sync after every execute, and then even if the second one fails, Boba Fett will still be inserted. But now, in this current flow where sync is only at the end, Boba Fett will not be inserted because it skips all the other messages. And it actually rolls back until the most previous sync point by default. But you can actually start transactions, and then you get some different behavior where it actually rolls back until the transaction. But it basically also automatically opens the transaction this way.
So I have a question about that. You said, so on rollback, are you saying that each sync is in like an implicit save point, or how is it? Because I thought Postgres basically just, once you hit an error, gives up the transaction unless you have save points.
Yes, but so this is, I mean, if you don't do begin here, then there's not really a transaction. So
if it's an implicit transaction.
Yeah, it becomes an if you don't do anything, it becomes everything between the first statement after the previous sync and the next sync becomes an implicit transaction. Okay. Just like how one query normally becomes an implicit transaction, but because you split the query up in multiple messages, it's also a bit unclear what it means to fill just the one query, because I don't know, maybe it's
Okay, so if you're doing implicit transactions, sync is effectively a commit.
Yes. Okay. Yes, sync becomes a commit.
Does it roll back the number 2?
Yes.
Define Yoda, so there's no Yoda, there's no Boba Fett.
Yes. Right now, yes. If you would put like begin at the start, like if you would put a begin and a commit before the Yoda, then you would have like an explicit transaction first. But if you don't have any explicit transaction, like an implicit one will be opened, and it will continue like this. So let's talk a bit about the copy protocol, because that's also...
One question.
Sure.
When you prepare statements on the SQL level, there is a deallocate to let the server forget about the prepared statement. There is none in the libpq protocol. Not a protocol message.
There's a close message which you can use to deallocate a prepared statement again.
Oh.
It just still not really, but in PG17, libpq will actually have a function to create that message, but that message existed for a very long time. It's just that libpq is sort of it's the official implementation of the libpq of the Postgres protocol, but it's not a very good implementation of it. It's missing some features. Like you can also not specify, for instance, that you want binary only for a certain column, even though the protocol allows this just fine. libpq is like, oh no, you can have binary for everything or text for everything, and then that's it.
Secret messages.
It actually handles binary stuff pretty well.
Yeah. Yes. Let's talk a bit about the copy protocol. Basically, it's just like the other the query protocols, but for sending the query. But then instead of getting data rows back, you get a copy out response, and a copy data, and a copy data, and a copy done. And this is if you copy from Postgres to the client. And if you copy the other way, from the client to Postgres, it sort of goes in the opposite direction. You still get a copy in response from Postgres, sort of notifying the client that Postgres is expecting copy stuff. And then the client will send that copy stuff and be done. And there's one really weird thing that I only learned quite recently, is that Postgres ignores sync messages until a copy done happens, after you create this query. So if you would put a sync right after this execute, normally that would be sort of like an implicit commit. But here, you can put as many sinks as you want, and Postgres just drops them on the floor. It doesn't care about them. And that might seem a bit weird, and it is. But there's a good reason for it, which is that many clients, they want to just send a query, and then they just do prepare, bind, execute, sync, so that it's all committed and it's good. And if they don't know if the query is a copy from standard in, which it most of the time isn't, unless you're, I don't know, copying lots of stuff always, then it kind of has to wait to see this copy in response otherwise before it can send a sync. Because otherwise the sync would be illegal, because it would still need to send a copy done first. And even if it didn't, maybe it would want to check stuff. So that's a really weird little quirk that I recently found out about when someone reported a bug in PG Bouncer. And then, final thing about the Postgres protocol, as it is now, is the cancellation protocol, which works quite different than most of the other things. Because most of the other things, there's a single TCP connection that you send messages over. And the way cancellations work is basically like this. The client connects, and the server then sends back, oh, all right, here, right after the startup message, one of the first things it gets is a message back saying, if you send me secret token 123, then I will cancel whatever is running on this connection at that moment. And so if you then run delete from users, and you realize it's taking much longer than you meant because you forgot a where clause, you can send a new connection request with this special cancel message. But it's a separate TCP connection. It's a new connection to Postgres. And then Postgres on the other connection, it will send like, oh, I canceled your query. And this is again one of those 4 2.0 messages that contain a version number at the start. And this is finally the 1, 2, 3, 4, 5, 6, 7, 8. It's the initial one that was weird. And yeah, you need a new connection. And one thing that it does is it closes that, you need to close that connection immediately. Postgres, the way Postgres says like your query is canceled, to the one canceling, is saying, oh, all right, I'm going to close the connection, you're done. So every time you want to cancel, you have to open a completely new connection. So yeah, well, that was all the sort of how the protocol works. I mean, you can send queries with it, and people do it, so it's quite good. So yeah, what's bad about it? Well, basically, all of that can be boiled down to this. It's old. It hasn't seen changes for 20 years, and it's starting to show a bit. Well, actually, that's not really true. There's been one change, which is a very useful change. It's that Postgres has, 5 years ago, a new message was added, which allows you to negotiate the protocol version. But that's never used, because we only have one protocol version. And we don't have any protocol extensions, which is also allows to negotiate. And so, yeah, right now, because it's old and people noticed it start to show its age, we're now discussing a bit how we can use this message to get all the protocol changes in that we want. So yeah, let's talk about more detail about what's bad by showing how people want to fix it, and explain a bit what the Postgres protocol might look like in the future. So the first thing is direct TLS. As you remember from the start, if you needed to do TLS encryption, you first needed to send this TLS request, SSL request, and that's it's kind of weird, because if you connect with HTTPS, you're not going to ask first, like, hey, can I connect with HTTPS? You're just going to connect with HTTPS and figure out, oh, it failed. All right, OK, I can't. So that's committed for Postgres 17. I mean, you never know if it's going to be reverted, but it seems fairly probable that it's going to be in there. And this will reduce one round trip when setting up the Postgres connection over TLS, because you don't have to ask first. You just go and try it, and if it works, everything's good. And one other big benefit is that now you can use off-the-shelf TLS proxies to do, for instance, TLS termination, so that you can because those proxies would previously need to understand this weird handshake from Postgres-specific handshake that's like, I want to do TLS. All right, okay, I can do TLS, and basically no proxies actually supported that, or probably some do, but many don't at least. And now anyone that does basic TCP SSL termination, TLS termination, is going to be fine. And the way you enable it in Postgres 17, you can only use it with Postgres 17 and libpq 17, is by setting SSL negotiation direct in the connection string. And then you can use this and try it out. So if you care about sort of fast reconnections to Postgres, I definitely recommend that. It's not implemented in PG Bouncer yet. I haven't had the time.
Just a quick, sorry, because the protocol negotiation isn't there yet. Like, so if the client is a Postgres 17 client and tries to set this and talks to Postgres 12,
yeah, it will fail.
the connection, like, does it fail gracefully or like? What sort of failure does it have?
It drops it, and it doesn't have a way to. You can't do prefer anymore. No, yeah, because that changed a bit in the last few weeks.
Specify direct. So you're saying I want to connect direct, and then say if it fails, it fails.
Okay, and it's just the client will be like, server couldn't
do it.
Yeah, the server will receive the message, and the server will be like, I have no idea what this is.
Yes. Yeah, it would be similar as if you said SSL mode equals require and connect to like Postgres that doesn't have TLS set up.
Right, it just drops.
Yeah, or if I just send garbage, I tell that to the server and send garbage. Because from the server's perspective, it's garbage, right?
Yeah, it drops garbage.
Yeah, okay.
Yes, so I wanted to just clarify that the way it actually works, you showed these various SOTA packets, it's 4 bytes at the beginning. The way this direct SSL actually works is that it looks at the first 4 bytes and recognizes that that's actually the first 4 bytes of the TLS connection. And that's how it recognizes it. So if you do a direct connect to an old server, that will in turn look at the first 4 bytes, see what protocols this is, and it's going to have some other number, right? That doesn't recognize what you say this. I don't recognize this.
Okay.
One that we call never uses the protocol version.
Right. In some sense, we have to then make sure to not use those byte combinations for future protocol.
But that seems like a problem for future us.
Would it be problematic to backport? What will break?
It's a new feature, so we don't backport new features. I think that's sort of the gist of it. So the second thing I want to talk about is compression. Because compression is kind of nice, especially if you transfer lots of data. And especially if you're on like a Wi-Fi connection or just across data centers or something like that. It's really nice if you do a big copy or like a base backup, and you wouldn't have to actually send all the data over the network. So that's one thing that we're working on as well. And that's basically, there's a special compressed data packet that would specify what compression method it would use, and then some bytes that's compressed. And the server or the client would uncompress those. And then they would see the actual message. So it's sort of a wrapper, it's like a message wrapper around real Postgres messages. And that's, yeah, there's a patch on the mailing list. And there you can set like compression equals LZ4, and then we'll use LZ4 compression for a bunch of different messages. And stuff will be faster. And then there's another thing, because one of the sort of the big things that could be changed is just make the Postgres protocol a bit more efficient on the wire. And one of those is binary encoding, because now it's really hard to efficiently request binary columns, because you need to request which columns you want to be in binary format. But when you send the query, the client might not actually know what it's going to expect there, because it might be just a query string that the user inputted, and well, you don't know if this column is a text or an integer or some JSON or a PostGIS object. Maybe some don't even support binary encoding. So to be able to find out you can find out what types this query is going to return. But for that, you need an extra round trip. You need to say, I want to do this query on the server. Tell me what this query is going to return, and then actually do the query. So you have an extra round trip for every query, which is not great. So that's one thing that people want to change. And basically, the idea is that you would have a separate setting, binary formats, and you could specify either the type name or the OID, some identifier of the types that you would always want to be binary encoded because you know how to decode them. Because maybe some you don't. Maybe PostGIS thinks they have a binary encoding mechanism, but the client doesn't know about that, so it rather just gets the text. And by setting that setting, and then instead of asking for binary or text, you would ask for this auto format, where if Postgres is like, okay, right. If it's auto, then let me look at this list. Is this type of this column in the list? All right, then I'm going to send it this binary. I'm going to tell you it's a binary column, or it's going to be in the text, and I'm going to tell you it's a text column.
Why do you need the auto format?
I mean, it's a good question. Because you need to request. Maybe you still want all the stuff in text. Maybe for sometimes you don't.
So which way does it go? Coming back to me or going to?
You would on the client would say, I want the columns in the auto format. Like just like you now say, like I want these columns in the binary format. You can say, I want these columns in the auto format. And because there's just also like a byte. You need to put something there. So you might as well put a new number.
You can ask for all of them to come in some format. So.
Yeah.
I think you did it, but I didn't have to do it when I did it.
Well, isn't that binary formats equals something that the client specifies?
Yeah.
I know about these column types, these data types.
Yeah, so both
you
of these
can
things-
send these in binary. Everything else, please convert to text.
Yeah. So
And that eliminates the round trip.
Yes, absolutely.
Don't you love
Good idea. wasn't it?
elimination?
yeah. All right. So another one is that there's smaller rows, because actually this data row type that we have is not really efficient. It's kind of has a lot of random stuff in there that's really not needed for every row. One thing is that it shows you the length of every field in this row, of every cell. And that's kind of not necessary for fixed width data types. If you have a 64-bit integer, you know it's going to be 64 bits. You don't have to have the server tell you over and over and over again that it's indeed 64 bits. You could get this information once from the description of from the row description, from like the column types, and then that could tell you like, oh yes, this is going to be a size. You don't have to worry about it. But instead, we have this over and over and over again for every row. And also the amount of columns that you get, it's also in there, even though you could also get that from the row description. So especially if you have small data types, this overhead becomes quite significant. So if you return like a list of integers, like just one column of integers, this overhead is most of your row. It can be like 2 or 4 times like the size of the data that you actually want to fetch from Postgres. So it's kind of a waste. For this, there's no really official proposal yet. Also because there's many ways in which this could be improved. There's also more radical approaches, which is there's a paper about this from some researchers that implemented, instead of returning a single row at a time, you would basically return multiple rows in sort of column order format. So you would have like first 100 values of column A, then 100 values of column B, then 100 values of column C. And then you can, that makes decoding much faster because you can use like SIMD operations to parallelize some of that, and it makes decoding faster. And it also makes compression generally more effective because data types that are close to each other, they are close to each other in the binary blob. So that has lots of advantages, and in their paper they show like a 4 to 8 times improvement over transferring lots of data from Postgres using a select, basically. Like just creating some big table and then doing select and waiting how long it gets to the client. With their prototype, they can get a 4 to 8 times improvement on that, which, I mean, it's probably worth looking into that once we figure out how to do protocol changes. So then there's another thing, which is a bit of a one I care about a lot, so that's why it's in here. It's GUC report, which is something that most people don't know about. But for GUCs, parameters for Postgres sometimes sends the client what the value is. But it does that only for a few of them, like application name, client encoding, date style. And the way that's basically determined which ones they are is because PSQL needed those. So PSQL got what it wanted, and it got those ones reported. But all the other ones that people might care about, they don't get reported. And for connection poolers, this is super useful information to get. Because if people want to set certain settings that survive their session, if you hand off this transaction to another session, to another connection to Postgres, maybe that setting that they just set is not going to be set there, or some other client just changed it again. So everyone is going to be very confused. So the only way right now to really solve that is just not do that. But people kind of want to do that. So it would be really nice if we could report more of those settings back to the client.
So that's not the only state change that you can make incorrectly across shared connections, right?
No, there's many. There's many state changes that you can make, but this one is sort of fixable. but not fixable right now because we cannot. I would like to fix all of them, but all of them require some specialized way of fixing them, probably. Some might never be able to be fixed.
I guess what I was wondering is maybe, like, I could imagine, because like another obvious one is advisory locks that are session level. And I could imagine having the protocol just tell you if there's like stuff that would cross, like generically just tell you there, things have been changed.
Sure. Yeah, no, that's definitely another thing that would be very nice, to be able to disable sort of this session level stuff with a setting and just error instead of making everything behave very weirdly and maybe correctly when you test it, but not in production. So yeah, but I think this set one, like, it's actually quite nice to be able to fix. People especially want to be able to use set search path, which is right now you cannot really use pgdump or pgrestore, one of the two, across PG bouncer, because internally it calls set search path, and then if it gets a new connection, that search path is gone, and every query that it will try to send after, it's not going to work anymore, or it's going to do something different, which maybe is correct, maybe not. So yeah, it would at least be very nice. All right, it would at least be very nice to do those kind of things. One other one is a larger secret in the backend data, like this. That's the packet that contains this cancellation token. And right now it's 32-bit, which is a bit small. I mean, probably not easily guessable, but also sort of on the edge a bit of what seems nice. And poolers and proxies might want to actually encode stuff in this token. I do that in PG Bouncer. I encode sort of what PG Bouncer sent the cancellation token, so internally you can route stuff around. And I know other people also want to do that for like having one proxy for multiple customers and then sort of encoding the customer ID or something in that token. So a longer token would be really useful. Another one is cheaper cancellations, because as I said before, you need one connection per cancellation, which is, I mean, you open and open and open and open connections, and most of the time you don't send any connections. But when you do send connections? When stuff is going wrong, and you have a failover, and now all your applications are sending cancellations, and that caused a failover again, and now everyone is very unhappy. So it would be really nice if you could send sort of batches of cancellations in like a way that doesn't require forking Postgres over in the postmaster process over and over again, and setting up TLS connections or TCP connections over and over again. Just have one connection and be able to keep that open and send cancellations over it once in a while or in bulk. That would be very nice. And then
Out of band.
yes, bulk but out of band, yes. Because in band, there's problems with how Postgres reads the packets. So it's really hard. That's hard to implement.
Yeah. I think TDS does out of band.
I know.
Yeah, TDS does
It
cancellation.
does.
So, and finally, there's this proposal for parameter set, which is basically sort of a meta proposal to be able to make all these connections options, all these changes. Maybe they're optional, maybe some clients want them, some clients not. But a pooler kind of wants to share connections across different clients. So if different clients want different connection options, they would need to keep a pool. If they cannot change what these options are after the initial connection setup, they would need to keep a pool for every combination of these options that clients might use, which explodes, and then your pooler basically doesn't pool anymore. So that's one thing I care a lot about in these discussions is making sure that we can change these settings on the fly so that connection poolers can continue to pool. So what now? Basically, we need some consensus on lots of things, and then we need to get stuff implemented and actually merged. I think that's the short of this. All right, I think it's time for lunch.